Welcome everyone to this hands-on session where we'll walk through a Python code that performs k-nearest neighbors KNN classification. In this video, I will explain what each line of code does so you can understand the process step by step. So to start off, in the first part of our code, we will import the necessary libraries. Libraries are like toolsets that provide us with ready-made functions for our tasks. We use libraries to save time and make our code efficient. So here we import the scikit-learn library, which is a powerful tool for machine learning tasks. We also bring in specific components like scikit-learn, like the wine dataset, functions for splitting data, the k-nearest neighbors classifier, and tools for measuring accuracy. The second part of our code involves loading the dataset. Just like gathering data before a journey, we need information to work with. In this case, we are using the wine dataset, which contains attributes of different wine varieties. So let's load the dataset. Set the x variable and the y variable. So we load the wine dataset from scikit-learn, which is a well-known dataset for classification tasks. We separate the data into features x and target labels y. Features represent the characteristics of the wines, and target labels are the categories which we want to classify the wines into. So next up in our journey, it's important to have a reliable map. This part of our code helps us divide our dataset into two parts, a training set and a testing set. The training set is like our map guiding us, while the testing set is like the challenging terrain that we'll navigate. So let's enter the code. So we have xtrain, xtest, ytrain, and ytest. So we use the train-test-split function to divide our dataset. Here we set aside 30% of the wine data for testing, and the remaining 70% becomes our training set. We also specify a random seed for reproducibility. Let's enter. Seems like there is an error. Let's check it again. I'll write this test here. Shouldn't be a capital letter. Y is not defined. Okay. Over here. This should work. Yes, it does. Now we introduce our trusty companion for this journey, the k-nearest neighbors KNN algorithm. KNN is like a seasoned traveler who relies on advice from nearby people. So we initialize the KNN classifier to be 5. You can change the value of k accordingly. And KNN is equals to k. I've copied it somewhere, so let's go with the line that was copied. Let's hit enter. So to give a breakdown, we initialize our KNN classifier. K is a parameter that determines how many neighbors we consult when making decisions. Here we set it to 5, but you can change the value of k to experiment with different settings. So with our map and our trusted companion, KNN ready, we set out to explore the wine world, it's like we are collecting information about the wines we encounter on our journey. So let's feed the classifier to the training data. So we feed our KNN classifier to the training data. This is where we learn from the map training set how to make predictions about wine varieties based on their characteristics. As we continue our journey, we come across new destinations, which is our testing set. It's our moment of decision, much like when we encounter an unknown place. Here, KNN takes the lead. So we use our KNN model to make predictions on the test data. It's like deciding which wine or variety bottle belongs to based on its characteristics. So next, as we reach the final leg of our journey, we want to know how well we have performed. The accuracy score measures our journey success. It's like calculating how many places we have accurately classified. So let's calculate the accuracy of the model. Y test and Y predict, and we print the accuracy score. And now parameter K, the accuracy, set it to 2 decimal place with a percentage sign at the back. So we calculate the accuracy of our model by comparing our predictions with the true labels in the testing set. The accuracy score tells us how successful our journey has been in classifying the wines. Okay, and there we have it. Our score is 74.07%. So in conclusion, this Python code takes us through a classification journey using the K nearest neighbors algorithm. We load the dataset, split it, train our model, make predictions, and evaluate our accuracy. It's like exploring new territories in the world of data, and KNN is our guide through the adventure.